If we have a projectile that's fired straight up into the air, in this case a ball that's thrown straight up into the air, then the height of that versus the time can be modeled as a quadratic equation. It's this equation that you're given here. The minus 16 is a number that's coming from um, the acceleration due to gravity. Gravity is 32 feet per second squared, and when you divide that by 2, that's where that 16 is coming from. 96 is how fast the ball is being thrown up, and 5 feet is the initial height that it's being thrown up from. And if you want to find the maximum height that it will reach, you can look at the vertex of the parabola, since it's a quadratic model. So we know that happens at negative b over 2a, which in this case, when you reduce that, you get 3. So that means after you throw the ball up, 3 seconds later, it will hit the vertex. It will peak out, and then it will start to fall back down. To find the actual max height, you then just plug in t equals 3 back into that height equation. And I wrote 16 times 9 as 90 plus 54. It's negative, so I did negative 90 minus 54. That's just because the 10 times 9 gives me 90, 6 times 9 gives me 54. I did the same thing with 96 times 3. I broke it up as 90 times 3 plus 6 times 3. It's just a quick way to make it more simple to add by hand. And in the end, I got 149 feet. And then to graph this thing, I know where the y-axis is. At t equals 0, I know the height is 5. I know where the vertex is. And those are really the only 2 points I need to be able to sketch a pretty good graph of this. A parabola is always symmetric about the line that goes through its vertex. So since the y-axis, the y-intercept is 5, and the vertex is happening at t equals 3, that means if I wanted to, I could also plot a point at t equals 6. I know that the height there would also be 5. So if I wanted to be a little more accurate, I could make sure that I hit that point.